Hello and welcome everyone to my channel Code with Ease. In today's session, we are going to discuss about merge sort algorithm. So far, we have discussed about three algorithms: the bubble sort, selection sort, and insertion sort algorithm. For people who are learning DSA for the first time or are here to brush up on their DSA skills, learning merge sort algorithm is an investment in itself because it helps to clarify a lot of different concepts, and using the same concept, many different types of questions can be solved very easily. So stay tuned. First of all, we are going to discuss an overview of this algorithm. Then we are going to move to the whiteboard to discuss how this algorithm works. We'll do a dry run also for that. And then we are going to write the code for this. And then we are going to discuss the performance of this algorithm. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So merge sort is a very efficient sorting algorithm. Why is it efficient? So far we have discussed bubble sort, selection sort, and insertion sort. Those algorithms have not been very well suited for larger data sets, and that is largely because of the time complexity. But in case of merge sort, as we will see later on, the time complexity of this algorithm is quite good, and that is why it is very efficient. This algorithm is based on divide and conquer strategy. What is this divide and conquer strategy? This is a paradigm, it's an algorithmic paradigm in which there are three parts. First is to divide, second is to conquer, and third is to combine. So, in simple words, given a problem, it tries to divide that problem into multiple sub problems, and then each of those sub problems are solved together recursively, and then finally the result, the outcomes of those are merged, and then the final output is given to us. Merge sort, quick sort are very popular implementations of the divide and conquer strategy. Today's merge sort algorithm, we are going to learn to do that on an array, and in that the array will be divided into two parts, and then we are going to see how are we going to apply merge sort to eventually sort that array. So with that, let's move to the whiteboard to understand this algorithm more in detail. So into the whiteboards, now we will understand how this algorithm works. And this is the array that I have taken, and eventually we will have to sort this array using the merge sort algorithm. So today's whiteboarding will be a bit different from what we do. So today, instead of discussing the algorithm and the pseudocode, we will first do a visualization of the problem, then we will do a dry run of the problem, and then we are going to see step by step how does this algorithm works, or we'll write the pseudocode for that. The reason being, if I first of all start with the pseudocode and write down the steps, it will be very difficult to understand what is happening behind the scenes. So that is why it is very important to first of all visualize how this merge sort is happening from the scratch. Once we are able to visualize and do a dry run, after that when we will learn the step-by-step approach and the code, it will be very easy to relate to that. So starting with that now, this is the array that we have and we will have to sort it. So as we discussed, this is a divide and conquer strategy that we have to use, which means given the data structure, which is an array, we have to divide this in two parts. So this is the array that I have. I'll also write the index values. When we divide any array, we know that we use pointers to manipulate the length of the array. So first of all, we'll use a left pointer, we'll use a right pointer, and we'll have a mid. So in this case, our mid will be over here. So from here till here, this will be one part of the array, and from this till this will be another part of the array. So left to mid will be one part, and mid plus 1 to right will be another part. So I'll just write it over here. So divide and conquer strategy says, first of all, divide it, fine. Second is, we have to conquer this, which means once we have divided it and we have got our sub problems on the sub arrays, now we have to try to do the same thing on the sub arrays also. Means when we have got this part 2591, this also needs to be divided into two parts. So consider here the left is here and the right is here. We have to find out the middle point. So same here, 2 and 5 will be on one side and 9 and 1 will be on another side. Again, coming to this, 2 and 5 will be divided into two parts. So on one side we will have 2 and on one side we will have 5. Similarly, 9 and 1 side we will have 9 and another side we will have 1. Now the moment we have only one element left, we don't have anything to divide again. So this will be our base case. So now we have to start returning the answers to the caller. Like we said, first divide, second conquer, do it on the subproblems, and thirdly combine. Now is the third step. We have to start combining the results. So in this case, when we will do combining is when we have to return the answers to wherever it was being called. So when it returns is where the actual merge sort algorithm takes place, means the actual sorting algorithm happens. So in this case, what happens is 2 and 5 is being taken. These are considered as like two separate arrays, and then these two are being merged together in such a way that now they become a sorted array. So 2 and 5, if we talk of ascending sorting, 2 and 5 are already in sorted array. So now from here what we get is 2 and 5 only. Fine. Similarly, coming to the right hand side, 9 and 1 will be returned back. From here, 9 will be a separate array and 1 will be another single array. It will be merged or it will be combined. In this case, the sorting algorithm logic will happen. Now in this case, what we see that 9 is greater than 1 and ideally 1 should be before 9. So now what will happen is, instead of 9 and 1, this will be 1 and 9 that is going to be returned. So from here, this is an array which has 2 and 5. This is an array which has 1 and 9. So now this will be returned to wherever it was being called from. Now whenever it is trying to return, again that sorting logic is going to be applied. So it will be applied on these two independent arrays. When it is being done, as we can see, smallest number is 1. So ideally it will be 1, then 2, then 5 and 9. This is the final array which will be returned to this array which was being called. So 2591 is now being sorted and now we get 1259. So this is all happening on the left subarray. We have not even covered the right subarray. So this is what I wanted you guys to visualize what is actually happening. Because now if I had shown the code and the steps, it would be very difficult to understand what is happening. Unless we visualize where is the dividing, where is the divide happening, where is the conquer happening, where is the merge sort algorithm actually taking in place, how is the combine happening, it is difficult to relate to the algorithm. So when you guys will also try to practice this, I would recommend to take a sheet of paper, write it down or use a whiteboard, whatever work, but write it down and then step by step see what is happening. So before we move to the right hand side, I'll just summarize it again. What is the summary? First we divide it. We first divide the array into two parts. Second is, after dividing, we keep on dividing till we reach a position where we have only one element left. Once we do that, then we start combining the right and left subarrays. The moment we are trying to combine is when we apply the logic of sorting. Because when we have to combine, we apply that logic of sorting so that the combined array that we get, the final array that we get, that array contains the elements in a particular order, ascending order or descending order, whatever is the requirement. So once this is done, we apply this logic and then return the sorted array to the caller, and this is what we do it recursively. This is what we keep on doing for every right and every left subarray. We keep on doing till we reach to the base, the final, the big fat array which was calling in all of these, which is this array. So now that we have done our left part, now we will come to the right hand side. So in the right hand side, same thing. So if our left pointer is here, right pointer is here, this will be our midpoint. So on one side we will have 7 and 6, on another side we will have 4. 7 and 6 will be broken down. We have 7 and then 6. 4 will be as is. So now 7 and 6 is done. We have one array. This is the base case that we have reached. Now it's time to combine. When we will combine it, 7 will be returned, 6 will be returned, and when the combine happens is when it is going to get sorted. So 7 and 6, we know 7 is greater. So this, the final array that will be returned after doing the combine logic is 6 and 7. And from here anyway 4 will be returned. So 6 and 7 comes from here and 4 comes from here. This again needs to be merged. So from here what do we get? 4 is the smallest, so we get 4, then we get 6 and then we get 7. So this is our array from the right hand side. But our story is still not complete. We have got array from the right hand side. We have got array from the left hand side, which is 1 to 5, 9. Now this array and this array also needs to be merged. So 1 to 5, 9 and 4, 6, 7 will also be merged. Then finally we will get our final array, because all of this was happening so far on the left hand side. And then it comes to the right hand side. Because once the left hand side is finished, only then it will go to the right hand side. Once the right hand side is finished, and then it is going to do the combination. So when it does that, finally what do we get? We get 1, 2, 4, 5, 6, 7 and 9. This is our final sorted array that we get. And this is what I wanted you guys to visualize first. How we are breaking down the array and going till the last element. And from there again how we are going up and trying to combine all the elements and then finally sort the array. So now let's step by step understand how the algorithm will be. So we'll have this merge sort function in which we'll pass in the array. We'll also have to pass in the left and the right pointers. Initially this left will be 0 and the right will be the length of the array -1. And since this is going to be called recursively, so first of all we'll need a base case. So like I said, if there is only one array left, sorry, if there is a, like I said, base case will be if there is only one element left. So we can say if, right minus left is equal to 0, means both the pointers are at the same element, means there is only one element left. So we will just return it. This is the base case. Then we will have the main body. So inside this we'll call this function only for the left hand side. Now we will do it for the left subarray. So inside this what we will do, first we'll pass in the array and then we will manipulate the pointers. So initially our left will be same, the right will be till mid. So what is mid? Mid also we have to calculate, right plus left by 2. Every time we have to recalculate the mid. So this for the left subarray we will call the function. Same thing we will call for the right subarray also like we did. But here we are going to call it from mid +1 till the right pointer. So that is what we are doing over here, right? From 0 to mid we are passing 2, 5, 9, 1 is one array and then 7, 6, 4 is another array. Same thing we are recursively doing for every smaller subarrays. So once we got the left subarray, once we got the right subarray, then what we have to do is we have to now merge it. So we'll call a different method called merge. Inside this we will pass in the array, we'll pass in the left pointer, we'll also have to pass in the mid pointer and the right pointer. And this new method what we will write is going to have the main bulk of the logic in which the combining of the elements is going to happen and finally the elements will be sorted. So let's take a look at how this merge method will be. So inside this merge method, we will have to create a new array. We can name it as mix, which will be equal to left subarray's length, left.length plus right.length. That is what we are doing over here, right? We were combining 2 and 5. So totally we were returning an array of 2 elements. So after doing this, now we already have the mid. So we'll have pointers. We can call it like the start pointer. So start will be equal to left. We'll have the right pointer, which will be equal to mid +1. And finally, another pointer, which is going to start from 0. Now this is critical. This is like, I feel this is the essence of this algorithm. What is happening over here? We have an array, which is the left array. We have, let's say 0, 1, 2, 3. And we have the right array, which is 4, 5, 6. I'm just writing the index numbers. So the start pointer is going to be equal to left initially, means start is over here. This is the left array. Right I am saying is equal to mid +1. Considering this left is over here, mid is over here. Like we said, left to mid is left array. Mid +1 is over here. Mid +1 and right is over here. So mid +1 will be equal to right. Why we are doing this? Because one pointer we are going to, for the left array, the pointer which we are going to have, it is going to run from left till mid. That is why we are starting from left. Once it runs till mid, after mid what is there? Mid +1. So for another pointer must start running from mid +1 only. I can just rename this to L1. I'll just rename this to R1. So this L1 pointer is going to start from left and R1 is going to start from mid +1. As simple as that. And this index 0, what is this pointer going to do? This is for our new array that we have created. So this is the empty blank array which is of this much size, left plus right. Inside this, we have to start filling in the elements in the correct order. For that, we are starting this index equal to 0 and we'll start filling it. So after we have defined these pointers, it's just about having a loop. And within this loop, we are going to have the sorting logic. What is the sorting logic? Nothing. This left and right subarrays are there with us. And these are the pointers that we have. L1 is going to run from here. R1 is going to run from here. It's a basic logic of merging two arrays. So what happens in this is we compare the element at L1 and we compare the element at R1. I don't want to write the code over here because we are anyway going to do that in the code implementation. I'll just explain. L1 and R1's elements we are being compared. If L1 is lesser than R1, then in that new mix array that we want, we will put L1. We will add L1 to the mix. If otherwise, if R1 is smaller, then else we will add in the mix R1. That's it. So in this way, what will happen is the smaller elements will come first in the mix array and followed by the larger element. So the basic logic, what will happen inside this loop is comparison of the elements of the left subarray and the right subarray, whichever is smaller, is eventually start getting pushed to the mix, that new array that we are creating. After all of that is done, now we have this new array called mix. We have got at the end of this, and this is containing all our required elements. Since merge sort algorithm that we are discussing is an in-place sorting algorithm, the one which we are discussing, what is in-place sorting algorithm? Whatever this array is given to us, this example array if we consider, we are supposed to modify the same array. We are not supposed to return a new array itself. That is what we are trying to do in this case. It is an in-place sorting algorithm, that is why. So this array, whatever this array object is, we are eventually going to modify this same array only and then return the sorted version of that. So that is why what we will do is we are not going to return the mix only. At the end, we are not going to return an array. Rather, we will use another loop to copy the elements of the mix, copy elements from the mix to our main subarray. Elements from mix to whatever the ARR we have. And ARR we already have it in our argument. Once it is done, then we are done with the combining logic, and then we'll carry on with the getting the newer left and right subarrays and doing the same operation again and again. That's all about the visualization, the dry run, and the algorithm. Now we will see the code for this. So as we know, this is going to be a recursive solution for this. So first of all, we need the base case. In this case, it is going to be when there is only one element left, as we discussed. So here we have the parameters left and right. So I'll say if right minus L is equal to 0, then we have reached the base case and we should return. Suppose that we need to calculate the mid, which is going to be R plus L by 2. And then we are going to call the functions with the appropriate boundaries. So we'll pass in the array. We'll pass L and mid in the first call. This for the left subarray. We'll copy this, and in this we'll pass in mid plus 1, and this is going to go up till the right. And finally, we are going to call this new helper method, the merge function, in which we are going to write the logic now. So we are going to invoke this. So what are these two steps like we discussed? First is the left subarray that is being generated, then the right subarray which is being generated. Once we have got them, now we are trying to combine it with this method in which we are going to have the logic for sorting this. So in this we are going to pass in the array as is, the left array, the pointers to the left array basically, and the midpoint will be mid and our right pointer. So we are creating a new array. You can call this as the temporary array. So now with that, let's define the pointers. So like we said, L1 is going to be pointing to the left subarray. So we can set this to left, or it is L. And R1 is going to be for the right subarray, which is going to be mid plus 1, or this is M. It's going to be mid plus 1. So M plus 1, because this is the parameter M, which is in which we have passed in our mid. So L1 is going to start from the first element of the left subarray. R1 is going to start from the first element of the right subarray, which is M plus 1. And finally, we'll have another index pointer, which is going to fill in the elements into our new array. So we are going to start it from 0. Now we are going to start a loop, and we have to start comparing both the subarrays and start the sorting. So in this, L1 is going to be less than equal to mid rather. R1 is going to be lesser than R because R is the last pointer. It starts from L, then we have M, and R is the last pointer. And R1 is the beginning, like we discussed. So into this, we have to start the comparison. So we'll say if ARR of L1 is less than ARR of R1, then mix of index is into this, we are going to put ARR of L1. We also want to increment the pointers of index and of L1. That is why I'll do the increment operation within this. So after this, index pointer anyway has to move one step ahead, and L1 also needs to move one step ahead. Else, if it is not lesser than, means R1 is smaller. So we'll say else inside mix of this, we will put the R1 index, that element of R1, and we'll apply the same increment operators. Is that it? No, because there's and operator in between both. So when either of them will become false, it has to come out of the loop. So it might happen that either the L1 has lesser number of arrays, lesser number of elements, so then this loop might break. In that case, we would still want to add remaining elements of the right subarray into the mix array or this temp array. I just rename this, it will be temp. So in that case, we have to separately write another logic over here. It's just the same thing. So what we'll do is, if at all right subarray exhausts, then we have to keep on adding the elements of the left subarray into the temp array. And similarly, if the left subarray exhausts, then you have to add the remaining elements from the right subarray to this. So R1 is less than R over here. So once we are done with these three while loops is when we are actually done with the combining logic, and now the elements are in its correct position in the temp array. Now what we have to do is we have to run one for loop finally. This is to copy the elements from the temp array to the original array because we want to do it in place. So we can say I equal to 0, I less than temp dot length, I plus plus. So within the ARR subarray, what we want to do is we want to start it from wherever it is initially there. So we can take it I because I is anyway starting at 0, plus we have to take L. Because in the left subarray, L will be a relative position. In the first iteration, it might be starting from 0. In the second iteration or in the coming iterations, all these values are changing, right? So if I have to change the elements in place, if I have to modify the original array, I have to put the elements in its relative position. So to achieve that, we have to add it by 0 initially, and then we have to keep on adding. So example is an array. So initially L will be at 6. So 6 will be, this is 0 index. So 0 plus 0 is anyway 0. So we have put 6 and 9 in its correct position. Now let's say the left subarray starts from 2, 3, 1. So in that case, L is over here, which is index number 2. So if it is index number 2, what will be the value of L? L will also be 2. Because that is what is the first pointer. That is what we are taking, the first pointer of the left subarray. So if index is 2, 2 plus 0 is 2. So then I'm starting putting the element from the 2th index. So that is why we are doing this I plus L. And then inside this, what we are putting, we are picking the element from the temp and we are picking it from the beginning, because in the temp we anyway have all the elements. We don't have to return anything. We have modified the array in place. So with that, let's compile and run this. Less than equal to mid. Okay, this will be M. Okay, it's my bad. These are not the arrays and the pointers, so it will be R minus L plus 1. These are just the pointers. So we want the array, the size of the array between that pointer. So we'll take R minus L plus 1. Okay, and there has to be a equals over here. Okay, so that's all about the code implementation of the merge sort algorithm. Next, we are going to learn about the performance analysis of this algorithm, the time and space complexities. So stay tuned for that. Now we are going to analyze the performance of merge sort algorithm. So far we learned that merge sort uses the divide and conquer strategy to sort the array of numbers recursively, and hence the time complexity required for merge sort should be much better than the previous algorithms that we discussed, that is bubble sort, insertion sort and selection sort. And that is what it is. The time complexity is order of n into log n. Now we have to understand why merge sort algorithm is fast. Of course, because the time complexity is good, but we need to understand the underlying reason why is it so. That is what we are going to discuss. If you guys have not watched the binary search algorithm video, I would link it up above and also link up the related playlists in the description. Do check it out. So when we learned about binary search algorithm, we have a connection with that. In binary search, something similar happens. That also kind of follows the divide and conquer strategy where a given subarray is divided into half and then further half repeatedly. So the input size n becomes n by 2, n by 4 and so on. The time complexity of binary search is order of log n, and hence because we are also dividing the array into subarrays recursively, that is why from there the log n time complexity is coming. But why the n is being multiplied with log n? When we are doing the merge, the last step, when we are merging the elements from the left subarray to the right subarray, we are technically traversing the entire array. And we are traversing it for how many elements? For n number of elements of the, how many number of elements are there in the array, we are traversing that many number of times. So that is why it is being multiplied with log n. So log n component is coming from the factor that we are dividing the array into subarrays recursively. And finally, when we are trying to combine those elements in the last step is when we are getting the linear complexity. So n is being multiplied by log n. And from there, we are getting the time complexity of n log n. And this is applicable for all the types of complexity, be it best case or average case or worst case. Coming to the space complexity, it is order of n, which is equal to the input size of the array. The reason being we are taking an additional array to store the elements in the merge function, and that is why whatever the input size of the array, that much additional space is also being taken as an intermediate array. Hence the space complexity is order of n. So with that, this is a wrap on the session for today, the merge sort algorithm. Hope you guys have enjoyed the session. Do check out the playlist for the sorting algorithm and also for the binary search. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.